All right, hello everybody. Welcome to first talks this weekend. My name is Ppu Molloy, and I run a website called Infinite NES Lives, and I help people publish NES games. And so I thought it'd be fun today to take 45 minutes, not an hour here, and try to show you how easy it can be to get started making an NES game. It's something that's always, before you do it, you think, oh, it's impossible. How is that? How can I do that? But we're gonna give it a shot here. I'm gonna start off just some questions about you guys to give me an idea of who I'm talking to here. So raise your hand if you've played NES games. Okay, that's what I thought. All right, so what about if you're interested in making games for the NES or being involved in part of that process? All right. And anybody here a programmer or have some experience programming? Okay. What about like music, chiptune, or graphics artists? Okay. How about people who have already made a game or an NES game or anything before? Okay, so it looks like a lot of these people, you guys in front of me here, have some of these skills. You've just never done it before, so I didn't think we'd get this many people in that group. But so here we go. So the goal of today, I'm not going to show you behind the curtain. Okay, so I'm gonna try to keep things simple, and I'm assuming that you don't know how to program in C, but it looks like maybe a lot of you already do. I'm not going to be getting into nitty-gritty details of the NES. We don't have time for that. This is not the end-all be-all. There's all kinds of stuff on the internet, and I'm just showing you how to get started, and I'll show you some places to go if you're interested in continuing. So we're going to give you a quick overview of the system architecture of the Nintendo today, and a little intro to programming, and then we're going to actually do it. So to get you a idea of the NES here, this is the memory map. So the NES is split into two separate buses. You have, as in any computer, the CPU, right, with 6502 run at 1.79 megahertz. And that is where all of your code is running, right? Now, just like your normal computer has a graphics processor, well, the NES has a PPU, the picture processing unit. So these two things operate at the same time on their own, but the NES, or the CPU needs to be able to tell the PPU what to do. It's kind of like its slave, and the whole time it's generating video to display on the TV, but the CPU can be running its own code. So that's why I have it separated into the left side, which is the memory map for the picture processing unit, and then the right side for the CPU. So the CPU has 2 KB of RAM available to it. The first page, 256 bytes, it's called the 0 page. The 6502 only has a couple registers, but these first 256 bytes kind of act like registers. And we're not even really going to get into that very much, but you'll deal a lot with that if you get using assembly. So we only have 2 KB of RAM, and we have a few registers that the CPU has where we'll make its rights to communicate to the PPU. And then the CPU on chip there's actually the audio processing unit. We're not going to get into that today, that'll be tomorrow. And also some registers to be able to check the controller status. And so above that, you see here I've got the middle is the cartridge connector. So everything on the top, that's actually the cartridge. So in blue here we have some memory, that's where your code is, your level data, audio, all of your data is going to be in there, and there's all kinds of different mappers and stuff. You can have extra RAM and extra functions available to you depending on which mapper you use. But then the left side in red is the CHR ROM or RAM, and that's where all the tile data is going to be, the actual tiles that the picture processing unit is using to draw the picture. So, so let's go ahead and get started here, making a game. So today we are going to be programming in C. A lot of people use assembly, and that gives you complete control, but if I threw a bunch of LDA, STAs up here at you guys, I think I'd lose you quickly. So we're writing in C, we're using assembler CC65, and it is going to take our C code and compile it into assembly for us. So we can actually go look at that assembly. It's not very fast or efficient. If you're actually making a game, at some point you're going to have to write some assembly, but it's not that bad, there's people to help. So we'll just write things in C and get going here. So I'm not going to explain a whole lot here, but we got the main function. There's a library, so Sharu is an active member in the NESDev community. He made a whole library for the NES to be able to use C. And it makes everything a lot easier for us, giving us functions. And he's already prepared the CPU for us. It's already running, everything's warmed up, memory is already cleared. So we're obviously going to enter in our program in the main function. We went ahead and created a variable. Now we're going to be, NES is an 8-bit system, right? So anytime you're instantiating a variable or anything, you want to try to use a byte. So in C, the way you do that is unsigned char, and then if you use an int, that's actually going to be a 2-byte variable. So it's going to span 2 bytes, and so here I have an example where we're just going to try to do something, but it's nothing on the screen, right? Well, we have our handy emulator here, and it's probably hard to see, but here's some of these variables that we instantiated, and you can see them incrementing every frame. But we want to have to not spy on the memory to do something. So we need to actually get into interfacing with the picture processing unit, so we actually see something on screen instead of just black here, right? So we've got our main while loop, and while this is going on, it's going to sit in this loop forever, right? But we don't necessarily, it's not that helpful to sit in the frame forever. One thing that we like to do is wait, so we only have this loop only runs once per frame, right? So at the very end of the loop, we're just going to call PPU wait NMI. So every frame, so there's 60 frames a second, and our while loop is going to run 1 time per frame. Once it gets to the end, it's going to wait. I'm not going to get into the timing of the PPU very much here, but you'll deal a lot with, there's only a certain amount of time that the CPU is able to talk to the PPU and modify this memory and everything. But for now, we're just gonna stay there. All right. So let's do some things before we get into our main loop. Let's we're going to start off, we want to turn the PPU off because we're going to be accessing this memory, and if the picture processing unit is drawing to the screen, we can't do that. It's a bit like walking across the street without looking. every frame, the PPU is driving a bus down the road, and you gotta cross at the exact right time to not get ran over and mess everything up. So we're gonna turn it off, and we're going to set some backgrounds. So we had the, we're going to set some of our palette data here. And we're going to see a little bit of the picture processing unit. Right here we have the PPU viewer. So right now, all of our palettes are displayed here in the bottom. And doing what we want here. Oh, I didn't do it right. We had an error there. Okay, so we're gonna set the palettes because we need colors besides black, and we're gonna go ahead and write a bunch of code on the fly here and make a bunch of errors. But yeah, so we set our palettes, and now we're still not seeing it. Anyway, we're just going to keep going. It'll figure ourselves out here. So we're going to start off, we're going to clear the screen. And we're going to go ahead and clear the OAM. We're going to get into that later. Oh, I know why. We forgot to turn the PPU back on, so we'll do that. And let's go ahead, and we're going to, so we don't have, you might be used to printf functions, right? You want to print something to the screen. Well, there's no operating system here, but we have some functions that the library makes available to us. And so we can use put stir, and we have to provide it the address of where we want it to go. I have a little chart here. So we have a grid, and we have to tell it where in this grid of tiles. So we have 32 in the X direction and 30 in the Y. So we're just going to go ahead and put it at position 7.5, and give it a string here. Instead of hello world, we do hello Portland.
Hello what?
Portland. And we're forgetting semicolons. It's important. All right, so I should get this to compile now. There we go. We're done. We have a game. Well, not really. Okay.
Great game.
We've actually got some on the screen, and we can probably, there. Okay, now we see something. These are the palettes that we loaded up. These are just some pre-made ones. We'll get more into that tomorrow. But these are the, earlier when we were talking about giving you the memory map, right, the pattern tables. Here we have these two pattern tables. We can actually see them live. Right now, we're seeing the same one doubled up. But you can use one of these pattern tables of 256 tiles for sprites, and the other one is for your background. Because those are the only real two layers that we have in the NES. And so that's not the only way you can do it, but that's the conventional way. So, now we're going to need to have any sort of game, we're going to have to get input from the user. And the way we do that is we have to pull the controllers. So one time we just call pad trigger, and that's gonna, we have to tell it which controller. So player 1 is actually 0, because we're computer scientists and we start with 0. So controller 1 is 0, and then controller 2 would be 1. So that's gonna go get the state of the controller and save it into memory, but we don't have to think a whole about that. We can just do something with that data. So you just use pad state and send it which controller you're using. And what specific button are we looking for, right? So let's, for this example, just do the start button. So this if statement, right? So first we pulled the controllers, and now we're saying if the state of the first controller, and then we're gonna AND it with this variable that we have available. Basically, it's just a mask for the one button. So all we're doing here is we're saying if the start button is pressed. All right, so we want to do something. And one thing that can be difficult with the NES, you know, if you've ever worked with electronics, lots of times you'll either print things to the screen or you turn the LED on. It's kind of hard if you're having a problem, you don't know what's going on with your code. It's hard to debug because everything's visual and you can't see your code well. So we have this fancy function, and Chris Parker, I used a lot of his code here. I'm going to show you his project at the end, but we have a crash screen, right? So we're just going to go ahead and crash the CPU when somebody presses the start button, right? So these are just some strings that we can send it, and then at the end you can send it if you want to print some current variable, right? So we're just going to print our fun meter here because everybody is having fun. We'll see what level here. So got some warnings, but that's okay. So I went ahead and pressed the start button, and now we have a fatal error. These are just whatever we typed in and the integer that we wanted to print. So this just gives you a way, you don't know what your variable is set to. Am I getting to this point in the code? You're just trying to find out where you're at. This is just a function that you can call from anywhere in your code, and it's just going to crash the CPU so that you know what's going on. All right, so now let's do something else. We can check a different controller or a different button, right? So instead of that, we'll just leave that there as the start button. But let's say pad up, right? So if they're pressing the up button, we're going to scroll the screen, okay? So you'll actually get to control it. So let's go ahead and we're actually going to need a 16-bit value. So let's call that Y scroll. So we'll set Y scroll and we'll start it at 0. And then every time the up button is pressed, let's increment that, right? So the plus plus, for you guys might know, that just increments the variable. So if it was 0, you press it, it's what it previously was plus 1. So it'll go to 1, 2, it'll just keep going up. And now we need to tell, we need to set the scroll value. We need to tell the PPU which position of the name tables that we're actually going to see. So to do that, we just use a simple function called scroll. And we're going to give it the X. For now, we'll just keep it with Y, with 0, and then pass it the Y value. So now, we should be able to see the screen scroll when it's really fast, but we actually have it scrolling. Now the NES, we'll go back here a little bit and explain a little bit more of the Ppu Memory Map. So I've got the PPU at the bottom here. These are the tiles up in the red that we talked about. Now, you can put the same tile in every single position on the screen. Well, the place where all of that data is stored is they call them name tables and attribute tables. So that's where which tile in which position, and then which color palette you want to use. And then there's actually 32 bytes of RAM inside the PPU that are the current colors in use. So the NES only has 2 KB for the screen data. So we only have 2 screens that we can use. We can change the orientation, but right now we've got it in a vertical arrangement. So we're seeing the first name table and then the second name table, and that's why we're able to get it. We have a different anyway. Let's give it a. Let's put a variable in the. So here we have the first one, we put it in name table A. So now let's print something in name table B in the same position. And we can actually see these name tables here. So we only have 2 units of memory, and that's why it's doubled up. So it's mirrored over. And if this worked, it didn't. I do it wrong here. Oh. I wrote it to the wrong one. So I wrote it to B, right? So A on the top left, B is over here. Well, it's mirrored over. I wrote it to B, so it's the same exact name table mirrored over. We actually want C. We want the bottom left here, right? So let's fix that. Now, we can scroll up and see the other, see hello from the other side. All right. So now we have some actual scrolling going on. Lots of people, when they're first making NES games, they think of scrolling as very complicated. And it can be, but you've got 2 screens worth of memory. So all you're doing is telling the PPU what's the top left corner, right, that you want to draw those screens. So all we did was we changed the position of the scroll value, and so it starts drawing in a different spot. Now, if you have, Mario Brothers, it's several screens long, so you have to keep changing that memory. So you have to draw it as it goes, and that does get very complicated. But if you only have 2 screens, it's pretty easy. So part of the reason that our scrolling was so fast was because this is a 16-bit variable, right? And there's only there's only 512. So this is kind of the acceptable values. So we were giving it values greater than 479, right? Because we just blindly incremented it. So let's go ahead and set up some logic there quick. So if y scroll is greater than 479, right? We want to reset it. We want to set it back to 0. So that should slow things down a little bit. Now we're only sending variables that are in the range that it wants. So it's a little bit more controllable now. And let's do something else. So that gives us the background, right? We put something on the name tables and they're being seen. But the other layer we have is sprites. So let's get a sprite on the screen and do something with it. There is some memory inside the picture processing unit. It's called the object attribute memory. This is where the PPU, it keeps all its data on which sprites are on screen, where do I draw them, which palette color are they using, and so that it needs that live time while it's drawing the screen, right? So we can't exactly write to that easily, and we want to be able to do math and change the position of the player in the middle of the screen. So what we actually do is we reserve 1 page of RAM for all of our sprite information, and then each time NMI comes around, the end of the beginning of the frame, that one time that we can cross the street without getting hit by the bus, we use DMA process that quickly copies all of that information over to the PPU. So we're just going to buffer that. And it's already taken care of. It's already taken care of for us in the library for the most part. All we really need to do is call our O. So at the beginning, I had an error because I didn't know what it was. It's not actually OAM clear. It's OAM. Yeah, OAM clear, not OAM screen. So we want to start off with that cleared. And the other thing that we need to do, well, we actually don't need to. So we just use this OAM sprite function. We have to send it a number of things. The first thing, we're going to need some more variables here to store where this player is. So we're going to want to move. So the first variable we send it is xPlayer. And then we need to send it the Y position. We're just going to keep it at a fixed space. So let's set him at, and here's our grid for the sprites. So we have an XY grid. Only 0 through 240 are visible, and if it's below that, it's off the screen, so it's invisible. And so we'll just give it a fixed position of 200 in the Y. And then we also need to say which tile. So the PPU needs to know which of these tiles in the sprites am I going to actually draw when I hit this sprite. So we're going to make it simple and pick a P for player and Portland. So you can see right here, if I hover my mouse over the P, this is tile number hex 30, okay? So that's which tile we're gonna use, and then we need to tell it which palette, right? We get a choice of our sprite, we got sprite and background palettes. Let's go ahead and make it red, so that'd be 0, 1, 2, 3. So it's palette number 3. And this OAM memory is arranged in the buffer that we've created. It's arranged in 4 bytes, so you kind of think of it as a struct. But we need to give it an index, and it has to be a multiple of 4. So we're just going to use index 1. This is the first sprite. Now we won't be able to see him very well if he's all the way off to the side, so let's put him down, let's put him over a little bit. And if we did it right, we should have a sprite on the screen. There he is. So we got 2 layers, but player's not very good if we can't move him. So we know how to do that. Let's say if, so we're going to do pad left. So if they push left, we're going to do the X position of the player is going to go down, right? If we go right, and we want the player to move right across the screen. So now we should be able to actually move our little sprite. There we go. Pretty fast. All right, so we actually got something moving on the screen. We can scroll. And we can move the screen. This is big stuff, guys. When you do this, when you go home and do this, the amount of satisfaction that comes from pushing a button and seeing something move on the screen, it's mind-blowing. I know I'm having a fun time up here, but trust me, that go home and do it. Even if you do nothing else, you're gonna make an NES game, you're going to show it to your friend, and be like, okay, no, but I'm moving the sprite. Look, I push the button and it moves. And other people won't be impressed, but you'll be having a blast. Okay, so let's we got a good guy. Now let's get a bad guy. Or so actually I had a hard time figuring out what kind of game to make for this. We need to do it quick. Everybody does Pong, and there's some math involved with is it hitting the paddle, are we going the right direction? It can get a little bit complicated just to sit here and talk to you guys. But, so my idea was instead, here at why is everybody here at Portland? Because they're here to collect games. Right? So let's have game cartridges coming down the screen, and your little player on the bottom, you're trying to get all your games you're collecting, right? So this is game collector. It was going to be dodgeball, and it was really easy to dodge one ball falling down the screen. So it's like, well, maybe we're trying to catch the ball. Oh, let's catch some cartridges. Okay, so we need some sort of logic for this Y position of the ball. But Oh, we need an X and a Y. So the Y position, right, up and down, let's just have it falling from the screen, right? So that's pretty easy. We can just say Y ball, decrement that every frame. So that we're putting that in the Y variable. And then this is supposed to be the X position of the ball, right? So we got to figure out, we want it to be random, right? If it's just following the same position every time, your weekend's going to be over quick. So there's actually a random function that we can use. I think it's just rand8 for an 8-bit value. So we did it all right. Oh, found it. Okay, so here's the index, right? So this is the first sprite. Well, we need to make this be the second sprite, and it's 4 bytes for each one. So the ball actually needs to be our second sprite here. Oh, it's all over the place. Yeah, that's going to be a little hard. I don't know if I caught it or not. What do we do wrong here? Oh, yeah, well, it's just randomly every single frame, a random X position, right? It did exactly what we told it to do, of course, as always. So we don't want the X position always to be random, right? We want it to be, once it gets to the bottom of the screen, right? Then we want to say, okay, new cartridge, you're in a random position X, right? So we're going to say if the Y of the ball is at position 240, okay, as it's falling down the screen, then let's make it random. Not just all the time. Oh, what's that? Oh.
Do we want to put the ball back at the top too?
Oh, well, yes, but here's the beauty of it, right? It's a byte, okay? Once it scrolls down, once it gets to 255, it decrements what's it going to be? 0. Right at the back of the top of the screen. It's already done for us. See? Beauty. Am I missing? No, there's so there's in the NES, right? When if it's 111111, right? 255, you increment it one time, the overflow bit will get set, right? But it just goes back to 0. So here it is, but now it's coming up from the bottom of the screen. It's going really fast. I'm not sure.
The weight.
You need parens on your weight.
Parens on my what?
On your PPE weight. It's just.
Oh, yeah, it's not doing anything. Thank you. That's why. That's why. And that's why it was really fast in the beginning. I thought it was because of something else, but.
Like, how is it valid without the params?
Which params?
Without the params.
I'm not an expert on this library. I just started using it, but there it is. Hey! So, yeah, it's coming. I want to come from the top of the screen, and that's because I wasn't thinking clearly, right? So what did I do? I said Y ball minus minus. The bottom of the screen is 240, right? So minus minus, it's going to be going up the screen. We want it to fall, right? So let's increment that. And now it'll actually fall from the screen. See, we're running close to time here, but I was going to try to do some logic to where we kept a score, but So we'll say if, we could do it as simple as the X player equals the X of the ball. That's going to be a little bit tricky, just because it has to perfectly line up. We don't exactly have, oh, it's going relatively slow. Maybe we can get it, but instead, let's say if the X position is greater than, right? So if let's say the X position of the ball is greater than the X position of the player, meaning that the ball is to the right of the player, greater than equal to, so it's lined up or to the right. And when we say, so that'll tell if it's on one side. Let's say if X, the ball, is less than X of the player, we're going to need some sort of width, right? We're just going to use 8. I didn't make a bunch of defines because I wasn't sure people would, who I was talking to here, but you guys are probably, I'm crazy with my magic numbers here, parentheses. Okay, so if it's within that range, right, to the left and to the right plus 8, we want to do something. Let's just make another sprite. So this is going to be the third sprite. Which tile should we use? Well, let's cheat. Let's use tile 1, 0, okay? But let's put it in a variable. Call it tile. But we'll start it. The first tile that this is going to be is tile 10, 1, 0. If this happens, right, we're just going to tell it to use the next tile as the sprite. So we're going to kind of have a score going. All we have to do is say tile plus plus. All right, so we need to actually put that not where the ball is. Let's just put that at position 50, 50, and the tile is now a variable. So now should have a score. Now it's not exactly perfect. There we go. Now it's fallen from the screen. It incremented a lot, right? So it just cycled through all of those. So we did this. This said if at any time this happens, right? But really, we only want to check this when the ball is right above the player, right? So let's insert a little bit of logic here. If y ball equals, we set that to 200, we hard coded that. So when the ball is at position 200, then we're going to perform this evaluation instead of all the time.
I need a second.
Okay, here we go. Oh, maybe we missed it. Oh, I think I gotta have it like right here. Hey, we did it! Okay, so yeah, that's a game in 45 minutes. I can't believe I did it. Okay, so I'm just going to give you guys a few quick things. Where do you go next? Well, first thing, you come back tomorrow. Same or close to the same bat time here. Tomorrow at 11, I'm going to be here. I think it's in the same room. And we're going to, now that we have a game, we're going to make it pretty. And if we have time, we'll put some music in it also. So come back tomorrow. But then also, and I'll try to figure out a way to get these links, but at least I'll talk about them quick here. So there's Nerdy Nights. This is how I learned to make my first Nintendo game, Pong, and I moved the screen on the sprite on the screen for the first time, and it was amazing. So this actually gets you all the way down right into assembly. You guys seem like you're pretty prevalent coders, but if somebody's watching this in the future, there's a website, learnc.org. It's a really good place to learn C. Here's the library of where I got all this stuff written by Sharu. So he has a website. Here's his library, and then he also has, it's really good, some examples. There's there's like 6 different examples here, and he just does super simple projects, and he starts doing things. So you can, I mean, this code is very, it's comparable to what we just wrote, right? So you can start doing other things. If you're understanding those, then you're making progress. Chris Parker, Chris CPP, he wrote this whole thing, NES Starter Kit. So it's almost like a top-down Zelda-esque game, and it's already running. And you can get in there and tweak it. And he has a whole tutorial where you go through and you modify his code and you add your own assets. So if you don't want to start from square one, you just want to start doing some stuff, you've got a game right away. And then if you're not interested in coding at all, but I think this is the wrong crowd, there's Nes Maker, which released recently, and Joe and those guys are moving that forward. And then there's also, this is a really good one, by NES Doug Fraker. This is more of a tutorial. He starts getting more explanations. He uses the same library as I was. So this is a good tutorial on nesdoug.com to give you some more stuff. So I'm going to cheat here, being out of time. So the whole thing I do, I like making hardware, right? I like making cartridges, and so I was going to program this and move it over for you guys, but we don't quite have time. So I'm just going to use it already flashed on here. At the end of the day, you get your game in a certain state, you can program it on the cartridge, and this one is a little bit more complicated with text all over the place, but you can actually play your game on the NES. So I sell boards and programmers to be able to do that, and you can write them rewrite them over and over again. Other than that, we have there's a homebrew competition. Every January it ends, and anybody who wants to make a game submits it, and we have prizes, and we make you get a free cartridge and put them on the same cartridge. And so if you do it yourself, get a group of people, even just get on the forums and say, hey, I'm really interested in doing this. Everybody's welcoming, and things have really progressed in recent years just because we're getting more teams. People are teaming up, and having that accountability of somebody else, like, hey, how far are we doing? It's helped out a lot. So things are growing rapidly. I also have a booth, 508 in the far corner. So if you have any questions, you can come talk to me or email me, whatever. But thank you so much, guys.